In the name of Allah, who is most beneficent and merciful. My name is Umair Habiba. I'm from Chemistry Department and my ID is 014. Today I'm going to deliver a presentation of environmental chemistry. The topic of my presentation is energy resources of future. First of all, there is an overview of my presentation which is related to the important topics like energy resources of future, which include atomic energy, solar energy, wind energy, and energy from biofuels. And the second one is future of some new energy resources, which include fuel cells, geothermal energy, and ocean energy. Then there are some contents of my presentation. For example, in atomic energy, solar energy, wind energy, and energy from biofuels. I'll discuss their short intro, their resources, about their short history, and at last about future of atomic energy, solar energy, wind energy, and energy from biofuels. Moving towards the topic, first of all, we see atomic energy. There is short introduction of the atomic energy. Nuclear energy is also called atomic energy. Basically, the energy that is released in significant amounts in processes that affect atomic nuclei, the dense cores of the atom. It is distinct from the energy of other atomic phenomena, such as ordinary chemical reactions, which involve only the orbital electrons of atoms. So the main difference in the reactions of atomic nuclei and other ordinary chemical reactions which only involve the orbital electrons of atoms is that the nuclear reactions relate with the tense cores of atoms while other only relate are involved with the orbital electrons of the atoms. Then we see what are sources of atomic energy. One method of releasing nuclear energy is by controlled nuclear fusion in the devices. And those devices are called reactors. Another method for obtaining nuclear energy is controlled nuclear fusion. So it can be said simply that there are two main sources of atomic energy: nuclear fusion reactions and nuclear fusion reactions. Here we see difference between fission reaction and fusion reaction. There is an example of the fission reaction in which you can see a neutron is absorbed by the uranium isotope 235, and in the fission process a large quantity of energy is released, radioactive products are formed, and neutrons are also emitted. While in fusion reaction, when deuterium and tritium combine, they form helium. Neutron is also formed, and energy is also released. But there is still difference among the fusion reaction and fusion reaction. But the energy released is released in both reactions. So we can obtain nuclear energy or atomic energy by both types of reactions. Then we see what is history of the Atomic Energy Commission and the history of nuclear energy. The science of atomic radiation, atomic change, and nuclear fusion was developed from 1895 to 1945, much of it in the last six of those years. But over 1939 to 45, most development was only focused on the atomic bomb. And onward from 1945, attention was given to harnessing this energy in a controlled fashion for many purposes. For example, one purpose is making electricity. But since 1956, the prime focus has been on the technological evolution of reliable nuclear power plants. So it is a brief history of the atomic energy and nuclear energy. Then we see what would be the future of atomic or nuclear energy, or what are suggestions to which we should follow in the future. From the perspective of where we will be in 2050, nuclear energy needs to consistently provide 8 to 10 terawatt of power. Terawatt means trillion watt of power in order to contribute to our future energy demands. To get 10 terawatt of power from nuclear energy, we need about 10,000 nuclear power plants. So it's mean we need to build at least one power plant in every 2 days until 2050. Since we have 439 operating nuclear reactors around the world, we need about 20 times the number of reactors we have currently, which is a daunting challenge to face. Daunting challenge means a challenge about which we have to worry. However, as uranium is not an unlimited resource, with this level of production, our uranium resource base would be depleted in 10 years, which means nuclear energy will not be able to be the main substitute for the fossil fuel. So, from this, a brief discussion, we can conclude that atomic energy will not be a sustainable resource of energy in the future. Next, we see solar energy. Introduction of the solar energy. The most attractive source of energy is probably the sun during daylight hours in sunny locations. Huge quantities of solar energy reach the Earth's surface, and this energy we can use also at the night time. So, it is solar energy basically. Solar energy is a renewable energy which is obtained by the use of electromagnetic radiation from the sun, and it is converted to the thermal energy and electrical energy. So they are the main uses or purposes of the solar energy in our daily life or in an environment. Then a brief history of solar energy. We start from 18th century. In 1839, French physicist Alexander Edmond Becquerel discovered the photovoltaic effect. We should know what is photovoltaic effect. Actually, it is the effect which is basically creation of electric charge, and this electric charge is produced as a result of exposure to light through the stimulation of electrons in the metals, for example selenium or platinum, which act as conductors. Second point is Alexander Stolitov developed the first solar cell based on the photoelectric effect in late 19th century. So it is the history of the late 19th century. Then after that, industry didn't begin to grow, however, until the development of a silicon-based solar cell by Bell Labs in 1950s. Throughout the 1950s, the efficiency of solar cells kept on increasing just like from 8% to 14% from 1957 to 1960. Since 2008, solar power has become increasingly popular as a renewable form of energy. And there are some reasons because its price became affordable to a much wider market. So it was a brief history of solar energy. Then we see what are environmental uses of solar energy. Solar energy can be used for heating purposes for homes. Solar energy can be used very simply to heat buildings and water. So in this diagram we see how it is used to heat up or heating for homes. Sunlight is entering through the glass of the window, and you can see it can be used for the insulation of the whole home because the air is warmed up, but still some of the heat is stored in the rock below the building for release because it can be used when the sun is not shining. Then we see heating for the other buildings and how we can generate electricity from the solar energy. In an active solar heating system, heat gathered in solar collectors located on the roof of a building is circulated by means of the pumps. In this diagram, you can see A plate of the solar cells, or you can say solar panel, is located on the roof of the buildings, and main purpose of their solar panels is to collect the photons from the sun, and they're turned into electricity. And the second step in the active solar heating system is that direct current is turned into alternating current because it is necessary to use in the home. And the third step, there are meters which can measure electricity of the solar system. In the solar collector, the glass plate allows sunlight to enter but traps the heat that is produced. Then you can see future of solar energy. Solar cells hold enormous promise for the future, particularly in developing countries such as India and Pakistan, where installing photovoltaic systems to supply electricity to remote rural communities is much cheaper than extending existing power lines. So it is one of the major advantages of the solar energy from which we can obtain it easily. The solar cells used in such systems charge batteries with excess electricity which are produced during the day, so that electricity is also available during the night. So this brief discussion concludes that this will be a sustainable form of energy in the future. Then we discuss about wind energy. Wind power or wind energy is the use of wind to provide mechanical power through wind turbines to turn electric generators for electrical powers. So it is a popular, sustainable, renewable source of power that has a much smaller impact on the environment compared to the burning fossil fuel. It means it is environment friendly source of the energy. In the wind energy, we use a term which is known as wind turbines. So we should know what are wind turbines. Windmills, which when used to generate electricity, are called wind turbines. Then we discuss about history of the wind energy. People used wind energy to propel boats along the Nile River as early as 5000 before Christ. By 200 before Christ, simple wind-powered water pumps were used in China, and windmills with woven reed blades were grinding grain in Persia and the Middle East. But by the 11th century, there was a development in the wind energy. So because people in the Middle East were using wind pumps and windmills, which were extensively used for the food productions in the late 80s and early 90s, what happened? Small wind electric generators were also widely used. In the 90s and 20s, the US federal government established incentives to use renewable energy sources in response to a renewed concern for the environment. So it was a main role which was played by the federal government in the process or development of the wind energy, by which we can use wind energy in future in an efficient way. So, what are uses of wind energy in an environment? Actually, it is used generally by humans for sailing, flying a kite, and to generate electricity. So, the main purpose of the wind energy in an environment is generating electricity. So, we see how electricity is generated by wind energy or wind power. The terms wind energy and wind power both describe the process by which the wind is used to generate mechanical wind energy into electricity using the aerodynamic force from the rotor blades, which work like an aeroplane wing or helicopter rotor blade, because they're actually working as propellers, like they push the air. So there is whole operation of a turbine which can turn a mechanical kinetic energy into the electrical energy. So first of all, wind which passes over the blades and makes them turn because of the kinetic energy. Then blades turn a shaft within the nacelle. What is nacelle? It is actually a box type shape which is located at the top of the turbine. Then the third step is the shaft turns a generator which converts the kinetic energy into the electrical energy. A transformer converts this electricity to the right voltage for the local network, and the finally electricity is exported to the electricity grid. And from the electricity grid, we can use electricity in our environment. So, what would be the future of wind energy? The Wind VN report shows that wind can be a viable source of renewable electricity, means successful source of renewable electricity in all 50 states by 2050. So, wind energy supports a strong domestic supply chain. Wind has the potential to support over 600,000 jobs in manufacturing, installation, maintenance, and supporting services by 2050. So it can be said simply from the whole discussion that wind is free and abundant, wind power produces no pollutants, no carbon dioxide, so it will be one of the renewable sources of energy in the future. Energy from biofuels. What are biofuels? Biofuels can be produced from organic matter, basically from the decayed organic matter like biomass, such as corn, sugar, vegetable oils, or waste feedstocks. Biofuels emit less carbon dioxide than conventional fuels, so they cause less pollution as compared to the fossil fuels. They can be blended with existing fuels as an effective way of reducing carbon dioxide emissions in the transport sector. So here we see history of biofuels. One of the first inventors to convince the people of the use of ethanol was a German named Nicholas August Otto. Rudolf Diesel is the German inventor of the diesel engine. Basically, he designed his diesel engine to run in peanut oil, and later Henry Ford designed the Model T car, which was produced from 1903 to 1926. Then we see what happened in the period of World War II. In this period, the high demand of biofuels was due to increased use as an alternative for imported fuel. In this period, Germany was one of the countries that underwent a serious shortage of fuel. It was during this period that various other inventions took place. And these inventions include like use of gasoline along with alcohol that was basically derived from potatoes. What happened after that period? With the increased supply, the geopolitical and economic interest in biofuel faded away. A serious fuel crisis again hit the various countries during the period of 1973 and 1979 because of the geopolitical conflict. But when the 20th century came, it came with the attention of the people towards the use of biofuels. Some of the main reasons for the people shifting their interest to biofuels were because of some reasons like rising prices of oils, emission of greenhouse gases, and interest like rural development. So it was a brief history of the biofuels, like how people started to obtain energy from biofuels and how they are getting energy from biofuels in the 20th century, 21st century. Then we see what will be the future of the biofuels. Growing pressure to lower emission and replace fossil fuels is leading to the biggest ever range of biofuels such as ethanol, biodiesel, and biomethanol and other green fuels. This green transition is a critical challenge facing the world, where a form of biomass is a major source of energy for cooking and heating for approximately 80% of the people in less developed nations of the world. So it may damage our environment. Because in many areas of these countries, the constant search for the firewood has led to excessive deforestation. And deforestation is not good for any environment. So, with resulting erosion and degradation of soil, it can ruin an environment. If trees continue to be cut faster than they are replaced, severe shortages of firewood are anticipated in very near future in many places in the world. So these all points show that energy from biofuels will not be a reliable source of energy. But if we follow some precautions, we'll use energy which we obtain from biofuels in an efficient way in the future. Then, second important topic of my presentation is future of relatively new energy resources, which are fuel cells, geothermal energy, and ocean energy. First is fuel cells, so I'm going to talk about fuel cells. A fuel cell is an electrochemical cell, means it converts the chemical energy of a fuel and an oxidizing agent into electricity. And that oxidizing agent may be air. So the practical fuel cell was first developed in 1959. Then we see um, short explanation of the geothermal energy. Geothermal energy is the heat energy that is generated deep within the Earth's interior by the decay of the radioactive elements. So it can be used in environment like heated groundwater may emerge as a geyser. Then, reservoirs may contain hot water or steam, and geothermal wells, which are basically like oil wells, can be drilled into these reservoirs to release the hot water or steam. And hot water and steam are used in environment for many purposes. For example, primarily they are used to heat buildings, and steam is used to generate electricity. Then we discuss about ocean energy. Renewable ocean energy harnesses the power of oceans to produce electricity, and they can produce electricity by different methods, like from waves. Using wave energy converts to generate electricity, and from tides using tidal barrages, fences, and turbines to generate electricity. So it is a predictable source of renewable energy with potential to satisfy. Here we see conclusion of my presentation. The most promising source of renewable energy for the future is a solar energy. As they become a great promising source of energy already. They are less expensive, more efficient, solar powered electric generating plants, automobiles, and numerous other products in which it can be used. So they are most common in our environment. Secondly, fuel cells and solar production of hydrogen are other promising long-term options. Then, future of nuclear energy is uncertain, but because of the fear of accident and problems with disposal of hazardous wastes, its use will probably decrease. But still, there are some reasons without we can't use all these resources in a successful way, which is without a strong commitment by the federal government to provide incentives for the conservation of the energy sources and to fund the research and development of economically and environmentally friendly acceptable new technologies. The transition from an economy based on fossil fuels to one based on alternative energy resources will not be easy. So, it was a brief discussion, our brief presentation on the energy resources of the future and future of relatively new energy resources. Thank you.